Alrighty, so to start off here, we just want to delete everything and we want to load in our reference image. Once we have that loaded in, we just want to line up the top left-hand image with the center of the Z-axis line. Once we have that done, we can duplicate the reference image, set the origin to be the 3D cursor, and rotate that 90 degrees around the Z-axis. Then we just want to align our side view, our top-down view, and our back view. Now, we don't need to worry about these reference images being too precisely aligned at the moment, as you'll see in a second, we're going to use a couple of vertices to properly align everything. So we're just going to load in a plane here, and we're going to bring it to the top of the helmet so we can get the right idea about where the positioning for the side and front views are. As you can see, we need to adjust the back view. And we'll duplicate this and we'll align it with the back of the helmet just so we can get the proper positioning for the side and the top-down version of the reference image. Now, this is pretty good and it's pretty reliable, though I just wanted to double check. So a good method that I've been using in my practice runs was to just line up the 4 points of the little inset details on the top of the helmet here. And as you can see, just using those 2 planes there, it lined up pretty well, but this just allows us to refine things a little better, because the last thing we want is to have problems with all of our perspectives as we actually get into the modeling process. With that said, we can bring in a plane and we can scale it down just so that the top of the plane is aligned with the top of the visor. We can cut this in half, delete the vertices on the left-hand side, and apply a mirror modifier to it. We're going to do this for the entire process, as it just means we only need to do 50% of the modeling. Now we're just going to align the bottom with the base of the visor there, and we can make some slight adjustments to the top so it's more properly aligned. Then in the side view here, we just need to bring it to the very front of the visor, and we can bring the right side all the way out to meet the edge of the visor. With that same edge selected, in side view, we'll drag that back to meet the very end of the visor. We'll put a cut through the middle, and this will start to allow us to align the visor with the actual shape. Now, we have a very basic set of mesh at the moment, but the benefits of doing this is that we can very easily define the shape we want, and then we can start to add more cuts and details later on. Now, with this cut, we want to align it with the second corner on the middle visor inset detail. This will allow us to properly align it from the front view as well as the side view as we start to slide the geometry around. So as you can see here, it's not properly positioned, so we can just move that forward, and that will start to provide us with the curvature of the visor that we're looking for. Now we're just going to go through with the loop tools out on here and just start to space some of these vertices out. And we can also do the same along the horizontal vertices. With that done, we have a more evenly spaced out visor shape, so we can add in some additional geometry since we have the basic curvature that we need. Once again, I'm using the top indent corner to align that vertice there from the front and side view. And now that we have the basic curvature, we can start to space everything out. The additional loop that we added, it's not quite properly in place, but we can just eyeball it and push it out a little bit. So for the most part, that is the shape of the visor that we want. And as I said earlier, now we can start to go through and put more detail to it. This just simplifies the process, as we started off with something very easy, means we had less vertices to manipulate from the start, and then we could progressively add detail and get to the end result that we needed. Now, I just dissolved those edges there after scaling in the bottom edge, as once we add them back in and then space them out, it just keeps a more consistent curvature in the design of the helmet. So we want to apply a subdivision surface to this, as later on this is going to serve as our shrink wrap mesh, and I'll explain that as we get to it. We're just going to use proportional editing here just to draw things out a bit, as the subdivision surface modifier does sort of shrink down our mesh a little bit. Now with all that done, we want to go through and name this mesh just so we know that this version of it is our shrink wrap version. I'm not amazingly consistent with naming all my meshes and vertex groups, though I would highly recommend that you do better than me and keep track of everything. We're also going to call this collection our references collection, just so that we're not accidentally selecting our reference materials throughout the process of trying to model. With that done, we can go ahead and duplicate our shrink wrap mesh, and then we can rename that to be our visor. Unlike what I've done there, you don't actually need to keep the subdivision surface modifier on our visor model, as we're going to use a slightly different method to get a hard surface result for the visor. In saying that, we want to apply a shrink wrap modifier to our visor, and we want to set the target to be our visor shrink wrap model. Now we can tab into edit mode on our visor model, and we can use the knife tool to start to cut out the visor details. In one of the first versions of this recording that I did, I used booleans to do this, and by all means, if you're more confident in using booleans, you can, though I found the cleanup process to be a little bit more tedious than just simply using the knife tool. So I would highly recommend you use the knife tool, and then we can do the cleanup from there. Though if you're more confident in using booleans, or that's more familiar to you, by all means you can do that. Once we have that cut out, we're just going to mark it as a sharp. The sharp's not actually important for any of the mesh normals or anything in the future. I simply do this a lot of the time just to keep track of where important details are. Later on, when we actually do use some booleans, I actually mark some of our creases as sharps, as I don't understand why, but when you apply booleans, it actually removes some of your creases. So that's just a side note for later on in the series. Now, with those details cut into the mesh, we're just going to go ahead and start to clean everything up. Now, our main points of detail that we sort of want to make all the quads revolve around are the vertices that we just cut into the mesh. Now, I say that we actually want this to all be quads, and we will end up having everything being quad-based, despite the topology being awful at the moment. Though the method we are using with shrink wrapping one mesh onto the other, you can actually get away with having triangles and n-gons on the model. Now, we are going to keep our visor completely quad-based, though I just wanted to note the fact that that was an option, though we are not going to do it in this case. We're just going to continue to clean up some of the cuts we made here, as not all of them actually line up properly from their respective orthographic views, especially since we are working with a curved surface. Now, I'm just going to let this part play out without any commentary, as all you guys need to do is follow along with the vertex manipulation that we're doing for the topology here. It's really hard to go wrong with anything we do, whether you use edge slides or you just use the general move tool for your vertices. It's not going to matter that much because we have that shrink wrap modifier. So as you'll see, we have a massive n-gon right in the middle of the visor at the moment, but with the shrink wrap modifier, it is actually compensating for us and it's keeping everything in the same shape. So I'll leave it here and I'll get back to you guys once we start doing some more tricky stuff with the shrink wrap modifier. Alrighty, so with all the topology for our visor laid out, what we're going to go ahead and do is select the sharps that we marked earlier, and we're going to give both of these a bevel so that we can start to do the inset details present on the visor. I just happened to notice here that there was a bit of a problem with the topology, just where it was connecting to the top edge. Just make sure you go through and check yours and make sure that you haven't had the same result happen. It's very easy to fix up. We just want to make sure we keep everything consistent with quads while we still can. With those bevels, we're going to put a cut through the middle of them, and then we're going to bevel those edge cuts in the middle as well. You could use an inset, though I find they sort of skew some of the corners. We're going to apply the shrinkwrap modifier, and then we're actually going to put another one back on top of it. The reason we applied the first one is we want to have it make all the corrections to the vertices. The second one is going to be responsible for keeping a smooth visor, but also allowing us to put the visor inset details in. Now, if you haven't already, we want to go ahead and make a vertex group. As I said, I'm not consistent with my naming, so at the moment it's just called group. We want to select those inner bevels, and we want to assign this group to those faces. With this, we're going to use that vertex group on this new shrinkwrap modifier. We then actually want to flip the influence of this vertex group, because what it's doing at the moment is ensuring that only those selected faces are being applied to the shrinkwrap modifier. When we flip it, it ensures that those selected faces aren't actually affected by the shrinkwrap modifier, and instead keeps the rest of the visor perfectly smooth. Now, if you don't want to go along with this specific design that I'm doing, that's fine. You can actually do any sort of visor detailing that you want. And since we are using the shrinkwrap modifier method, you could get away with pretty much any sort of design and not run into any major distortion. There's probably some exceptions to that, but for the most part, I imagine you could get away with almost any design that you want. So these sharps have pretty much served their purpose. So what we're going to go through is select all of them, and we're actually going to mark them as a bevel now, because we are going to use the bevel modifier in tandem with the shrinkwrap modifier. I'll save you guys a bit of time here. Don't set the width type to be %. We want it to be offset, though we do want the unit method to be weight. Setting the unit method to weight allows us to control exactly where the bevels are going to be with that mean bevel weight. So as you'll see, I'll change it over to offset, and then we can muck around with the amount to get the type of beveling that we want. Once again, I'll leave it there for a bit until we get along to changing some of our features in the shrink-wrap mesh. So at the moment, you'll notice that our visor isn't actually completely square at the edges. So to fix this, we want to tab into edit mode for our shrink wrap mesh, add a crease weight of 1 around the edges, and then on our actual visor model, what we want to do is we want to drag the point to the very edges of our shrink wrap model. This will allow us to get a more squared off visor shape, and it'll avoid a problem that I had very late on in my first attempt at this, and the visor wasn't actually properly lined up with the borders that I created around it. After we've done this, we're going to apply the modifier so that it actually puts all of the modifications into effect. As you see there, I just toggled the shrink wrap modifier off, and you can see that the geometry was completely out of the bounds of where we needed it to be. So we'll just go back ahead, we'll apply the group, and we will set the target to be the shrink wrap mesh again. And that's just going to fix everything up, and it'll all be nicely squared off. Now, I accidentally missed the inner edges of the bevel, so I'm just going to go ahead and fix that up. So with that done, we're almost at the end of the first episode of this series. But before we wrap up this one, we want to go ahead and select the top and bottom edges of the visor and duplicate those. These are going to serve as the foundations for the black visor brim. Not much is going to be done with the brim until a few episodes down the line. Although, much like modelling the visor, it's going to help us get an idea of the shape and profile of the helmet and help us influence other areas of the helmet modelling process. We want to delete the two vertices responsible there for the visor inset detail. As for the brim, all we want is the general shape of the visor. For the top and bottom edges, we want to extrude them and push them up and down for their respective positions. The reason we're doing this is because we're going to feed these through a solidify modifier. Using a solidify modifier is just going to save us unnecessary hassle with modelling, and it's going to keep the process a lot more non-destructive. We just want to set the offset to be 0. This way, when we use the solidify, it will keep the mesh in the middle, so we'll get an even distribution of the extruded mesh on the inside and outside of the visor. Once we have this done, we want to extrude 4 vertices on the bottom part of the brim, and we want to extrude these up to make the mouthpiece that is connected to the visor. We are going to use a shrinkwrap modifier again and some vertex groups for this. This just will save us a lot of time and hassle in having to try and match one shape to the curvature of the visor. Much like before with the visor, we're going to assign a vertex group to those 4 selected vertices. We're going to get a shrinkwrap modifier, set the target to be our visor. You could also set it to be the shrinkwrap visor, and then assign that group to the selected vertices. What we want to do from here is add more density to the mesh so that the shrinkwrap can more effectively work. Therefore, we just want to add in 2 more loop cuts, and then we want to adjust where the vertex group is having an effect. So we'll just add those back in. For the most part, this looks alright, although I can notice right down the middle of what we've just added in, the vertices and edges aren't actually perfectly aligned in the middle. So once we go ahead and space out all the vertices along the brim here, we'll just go ahead and fix that up. And we're going to fix that up by doing some scaling on the Y and Z axes, just so that it all is laying completely flat to that of the visor. And the shrinkwrap modifier will do all the heavy lifting for us. I just pulled the mesh of the mouthpiece forward of the visor so that it more accurately shrink wraps to that of the visor. This has also made some discrepancies in the straight edges, so what we can do to fix it is dissolve those 2 edges and add them back in, and we'll have a nice straight edge. With that said and done, we've finished modelling the visor and the brim. So that will be the end of our first episode, and we can move on to doing some more modelling on the helmet in the second.